Okay, we are live. Did anybody have any questions about this week's homework?
Just the 8D one, but
Okay, let's pull that up maybe.
okay, I have it.
Okay.
I'll just read it and maybe one of you will remember it. So it was talking about the Graduate Management Administration test, the GMAT, and the MBA programs, and it gave you the normally distributed with a mean of 529 and a standard deviation of 113. And it said, consider a simple random sample or n equals 10 students taking the GMAT. And so I did that, and it looked all normal, but the standard deviation is not the same. Everything else is the same.
I'm gonna pull it up right now.
So you're talking about D, you said?
Yeah, D.
D.
Mm-hmm.
Did you use a little equation that was in the book?
Yeah, the standard deviation divided by the square root of the number, which is 113.
Well, yeah, but that's not the answer in the answer key.
Are you sure?
Yeah.
I got 75.73.
It said it was like 35.24 or something. And I didn't get that answer. Wait, what equation in the book?
It's the standard deviation divided by the square root of the simple random sample.
Okay. And do you just pick a random sample?
No, it says
So
here.
up at the top, the simple random sample is 10.
Okay.
So it's 113 over the square root of 10.
Okay, you are right. I just didn't know how they got that.
I was confused on that one.
Yeah, I was
Yeah,
too.
it took me a while too.
Okay. So I guess it helped me a lot, like you guys just said, to have the textbook open for this lesson. I'm not gonna lie, this lesson didn't make as much sense to me as the other ones have.
Right.
So I guess we're getting into real biostatistics. But you guys want to start with the quiz and then just have the homework and have the textbook out.
Yep, let's do it.
It's lesson 6 group meeting quiz, right?
Yeah.
Yes. Please.
Yeah, it looks a little shorter than last week's or the week's.
Oh, good. Because it'll take us longer to do it.
Right.
So we're going to need the normal probability applet again. So you guys can open that up.
Yeah.
Oh, that's
There you
true.
go.
It's in the information question of the first question.
There we go.
Where do we get that again?
It's actually just in the quiz.
It's in the quiz. It has a link.
Oh, great. Okay, perfect. Thank you.
Okay. I can start if you guys want.
Okay.
Number 3. When you are taking a sample size of n equals 5, what is the shape of the distribution of means? Histogram when the parent population is skewed, right skewed. How do we find that? Does anyone? I don't think we use the applet, do we?
Actually, what it says right there in the question. So whenever you see, so it says the last part when the parent population is right skewed.
Yeah. So wouldn't it just be right skewed?
Yeah. That's
I think so, yeah.
So it's simpler than I thought. I was like,
yeah, because it's less than 30, the number, the sample size.
Okay.
So I think it would still be right skewed.
Okay.
I think even if it was more than 30, it might still be right skewed.
Because it says
because the parent thing.
You guys feel like,
If it-
you think that's too obvious of an answer or no?
I think it's the right answer. It just seems very easy.
Yeah.
So we're just afraid of it being easy. We can always take it a second time and
Yeah.
Okay, so I'm gonna do the group chat again with the answers.
Okay, that's a good idea.
Should I read the next question?
Sure.
Yes.
Okay. When you're taking a sample size of n equals 100, what is the shape of the distribution of means histogram when the parent population is skewed right? Right skewed.
I'm gonna look at the book.
Yeah, I have it pulled up right here.
I think it's normal. Because the size, I don't know if you had the chance to play around with the, whatever it's called.
The applet.
The applet.
It's
thing
not
we
the
get-
applet, it's the other one.
The other link. I'll open it right now.
Yeah.
But it shouldn't have mattered. Because when you went to, is it when you go to 10,000? Is that what you mean?
No, when you have a sample size of 100, it gets a shape of a
Bell shape?
shaped. Yeah, the normal distribution. Only when you use just a few sample sizes is when it's either right skewed or.
Because when you have enough information, it'll automatically come out with the average, basically. I think that's what you're saying, right?
I'm sorry, what was that again? I'm sorry.
When you get enough information out there, you're gonna have the correct
Yes.
average or mean, which would make it
It's going to be more accurate. Yeah.
Okay. That makes more sense.
So it's normal shaped, right?
I think so. Yeah.
But we
I
still
don't know
have
what you guys think.
that 3 is right skewed then.
Yeah, for that one,
Yeah.
For number 3, okay. Because I'm looking at the book right here. It says, if the parent population is normal, then the sampling distribution of X will always be normally distributed, no matter how many observations are selected.
If the parent population wasn't normal.
If the parent population is not normal, then the sampling distribution X will be approximately normally distributed if the sample size is large enough. If the parent population is almost normal, then a sample size of n equals 5 will probably be sufficient to assure that X will be approximately normally distributed.
Yeah, but later in the book it talks about the 50. Is that what you were talking about, Lydia? About the number 50 being a good amount?
yeah, I think it's, yeah, somewhere around, it's 30, I think.
Or 30?
A number higher than 30.
I found it. It says simulation can be used to determine if a particular sample size is sufficient. For this course, if the sample size is at least 30, we will conclude that the sampling distribution of X will be approximately normal. That's what it says.
Yeah.
You guys see my screen, what I'm highlighting?
Not anymore.
Okay, I'll have to keep talking for it to be pulled up.
Oh, yeah.
So if the parent population is almost normal, then the sample size of n equals 5 will probably be sufficient to assure that X will be approximately normally distributed. Is that not apply to question 3?
If you go further down, you can. One second.
The only thing is that little spot in the book doesn't say anything about it being skewed, so I'm not quite
Yeah.
sure if it would be normal or not.
So on the videos, there's the last part of, I think it's the last part of the second video. It gives you like a summary of the key points. And it says for the central limit theorem, it says As the sample size n increases and becomes large, the distribution of sample means becomes approximately normal. So the bigger the larger the number, the more, the normal it becomes, or the approximately normal.
Right. So probably the smaller the number, the more skewed it will be.
Yeah.
Because it's such a small sample that it can't really show an average.
Function is not normal, yeah.
Okay, that's good. Okay, so 3 is right skewed, 4 skewed, 4 is normal. I will read question 5. When you are taking a sample size of n equals 5, what is the distribution of means histogram when the parent population is normally distributed?
Normal.
Normal, yeah.
Okay,
This isn't that bad. We got this.
let's hope. Let's hope we don't get all of these wrong. Like this next one, say, when you are taking a sample size of n equals 100, what is the shape of the distribution of means histogram when the parent population is normally distributed?
That one should be normal too, I think.
Normal too. Yeah.
Crazy. Okay, who wants to read?
I can.
7?
I can if you guys want.
Okay.
Okay.
When would the distribution of means be normally distributed? Choose all correct responses. Data are drawn from a population that is normally distributed and the sample size is small. Data are drawn, let's do one by one.
Okay.
Data are drawn from a population that is normally distributed and small, so n equals 5.
I don't think it's normal then because it's going to be skewed because it's a small sample.
But they said even if the parent function is normal, then the small amount should be normal. I think.
Here, let's read through it because
Yeah.
it has like the little rules listed here.
Yes.
Where are you finding those rules again?
In the textbook.
3.1 when x is normal.
Mm-hmm.
Wait. Oh yeah, okay.
Okay, so I'm confused because I'm reading the textbook and I'm not seeing what you guys are seeing.
So if you go down in the textbook, it says 3.1 when x bar is normal. And it has these bullet points. The first one
Yeah.
talks about it being normal, the other one talks about it being not normal, and the ones below it talk about more specific situations.
Okay.
So I sound like a robot?
Yeah. Okay. Now, data are drawn from population that is normally distributed and the sample size is small. That is
That's fine,
not normal.
I
Yeah,
think
I
it's
think that's
normal.
not normal.
which is odd.
I don't
'cause
think it
normal
is.
my
In the
robot.
first one, it says if the parent population is normal, then the sampling distribution of x will always be normally distributed, no matter what the observations are selected.
Yeah. that's right.
Okay, you're probably right then.
So
So
then-
it probably is
So
normal.
then A is correct then, right?
Yeah,
Yeah.
the first one we'll check that one.
Yeah.
All right, number 2. Data are drawn from a population that is normally distributed and the sample size is large.
Normal.
No.
Yep. Data are drawn from a population that is right skewed and the sample size is small.
No.
Not
No.
normal.
Data are drawn from population that is right skewed and the sample size is large. That should be normal.
Okay.
That
Yeah,
should
I
be
think
normal.
so.
Okay, so 1, 2, and 4 are
Yeah.
checked.
Yeah.
Sweet.
So then that brings me back to. Oh, never mind. We're good. Okay. Lydia, do you want to read question 8?
Yeah. Which of the following gives the best explanation of the central limit theorem? I don't know if that's how you pronounce it, but the first one, if the parent population from which the data are drawn is normally distributed, then the sample mean x bar will follow a normal distribution. So yeah. Let me see actually.
The central limit theorem states that if a sample size is large, that x will approximately be normal.
Yeah.
So the second one says,
I
For
took my
bell
pen
ship
off, so
data,
that
which is
helped
normal
too.
distribution too. Oh no, this one, approximately 68% of the data will be within
So I
one
was looking
standard
forward to
deviation of the
quiz.
mean, about 95%. This looks like one of the homework answers.
So I think this one's just marking what the definition is.
Yeah, I think it's just the first one, right? Actually, if the sample size is large, the third one, the sample mean X bar will be close to the population.
I think it's C.
I think it's either B or C.
Let me screen share with you.
I don't think I think it's C, yes.
Yeah,
B,
I think it's.
I don't think.
Can I ask
Yeah.
why it's not D? Because look right here. I'm gonna have to just keep talking. The central limit theorem states that if the sample size is large, that X will approximately be normal. The law of large numbers states that the sample mean X will be close to the population.
But this one, D doesn't say that it'll be close to the population though.
Will approximately be normal.
But that's the
It's
law
close.
of large numbers, though, not the central limit theorem, right?
Yeah, I'm pretty sure.
Wait, if the
Well-
D reads, if the sample size is large, the shape of the distribution of sample means will be approximately normal.
I'm wandering around outside in the cold for a couple of hours,
Sample size is large,
and
X will
got
approximately be
really
normal.
wet and cold. Yeah, that's about.
Are those two different things?
Well,
Hashtag don't park in the wrong spot.
because the law of large numbers talks more about it being closer to the population mean.
Yeah.
So you might be right. Yeah,
It's snowing.
So
People
D
don't
probably
park
is the
when it snows,
answer.
apparently.
You were right. I was thinking of large numbers.
Mhm.
Well,
Yeah,
okay.
I have the same,
Fire zone,
we have the
zone,
same
the
question
entrance
for
to
the
some
homework
parking
for number
lots,
2, and
on the
it
sidewalk.
has the exact same. Actually,
All
no.
this-
it just has to explain it.
Actually, I think you're right, because the one for the homework is explaining the law of large numbers. So that would be C.
Right.
So I
Right,
think,
and so this one would
yeah.
be D.
So everyone agrees on D, right?
Yeah.
Hopefully. Or
I
if
don't know if I'm ever ready, but
I'm-
try to be.
okay, Katie, do you want to read question 9 and what goes with it?
Sure. Let X be a random variable with population mean U equals 10 and population standard deviation equals 6. Suppose a sample of size n equals 36 is drawn from this population. What is the mean of the distribution of sample means?
I believe so.
So is this when we use the equation?
It's not suddenly going to skew left. That'd be weird.
I think so.
But shouldn't it just be 10?
Yeah.
I think so. It's whatever the mean normally is, I think.
Yeah,
Let's see.
that was what it was like on the pre stuff.
Yeah.
Yeah, because so it should be that U number.
Okay.
And then 5.
I get a 1.
I got
Not sure
that
if I'm
one.
doing it correctly.
I think it's just the normal sample mean. So the U equals 10 up there.
Oh, okay.
Hashtag get done.
Because in the homework, or I guess in the preparation assignment, 8C says what is the mean of the sampling mean of the thing above, and the answer was just that U number.
Yeah, and since the law of large numbers is getting closer to the mean, I think it's going to be the mean. If that makes sense.
Sandy, if we're going too fast, let us down.
So you're saying that it's just 10?
Mm-hmm.
Let X be random. Okay. Do you all agree?
Yeah.
Okay.
And then this next one is the one that we use
Is it the
that
third one? Sample size is large, the sample
equation
mean
for,
X equals
I believe.
So you would take the mean, or 10, and divide it by the square root of 35. What was the number? 36.
You take the standard deviation and divide it by that number.
Divided by 6.
Well, isn't that 36?
Well, is it the square root of
I'll
30?
keep mine off the top.
Well, yeah, so it would be
Keep it up.
10 divided by 6.
Either way, it is weird.
It'd be 1.667, right?
Yeah.
Did you guys use the standard deviation as the top
I
number?
got a 1. So the standard deviation is
That can't
6
be on campus. Good thing we're doing it online.
divided by the square root of 36, right?
Is it?
Anyways, is that?
Is that the equation? Is it standard deviation over square root?
Yeah.
Mm-hmm.
Oh, okay.
I thought it was the mean divided by the square root of
That might be the law of large
standard
numbers.
deviation.
It's standard deviation divided by square root of simple random sample.
Which would be the
6 divided by 6.
10?
6.
6 divided by 6 should be 1.
Yep.
What?
Oh,
So sample mean is 36. So that's what you take the square root of. Standard
Gives you
deviation is 6. So
Okay,
6
that's what
divided
I
by
did
the
wrong.
square root of 36.
Okay, that's what I did wrong. So it is 1.
That's what we're going with. Let's just hope that this.
Hopefully we did it right.
That's what I looked in the book, and you're right. I just mixed up the 10 with a 6.
Oh, okay.
Regardless of the distribution of population, if the sample size is large and it's greater than 30,
so
what would be the shape, distribution, what would be the distribution of the sample mean?
Normal.
Normal.
Yeah.
yeah,
Do you want me to read the last one?
Yeah.
it'll turn out to be something. Really
What theorem
complicated.
would justify your response to the last question?
Law of large numbers, right? Or is it?
I thought it was the central limit
Central-
theorem.
Yeah.
I think, yeah, central limit theorem because of that other question.
Because, yeah, it's saying that it'll get closer and closer to the normal, and the large numbers, it'll get closer and closer to the mean,
Mhm.
which is about the same thing. I don't get, like, the difference very well, so.
Yeah.
Okay.
Let's turn it in.
Well, if we did 100%, that was the easiest.
Oh, I'm submitting it, so.
Oh, 100. Yay.
Really? Sweet.
Proud of
Woot.
you
We're
guys.
smarter than we thought.
It wasn't that hard, huh?
Yeah,
That's great.
no redos.
And we're done within the half hour. Isn't that awesome?
That is
Yeah.
awesome. So from now on, do you guys have a preference? Should we kind of touch base on like whether 7 or 8 works or you guys want to set a time?
Sorry, I missed that.
Do you guys want to set like a 7 o'clock or 8 o'clock time, or would you guys rather every week just kind of I can send out a text or an email and say what works best, just depending on the day?
I like 7, but if I have stuff at 7, I like doing it at 8.
That's fine with me too.
I like 7 too.
Okay.
'Cause it's been a long-
Let's shoot for 7, and then if anybody has anything going on, is it
Yeah,
okay?
maybe we shouldn't say that yet, or else maybe.
Yeah.
Yeah, that sounds good.
Let's do that.
I might need to use my 8 o'clock this Thursday. I will. Let's plan on 7, and then I'll text
Okay,
you.
Okay, perfect.
Okay.
sounds
Thanks,
good.
guys. I'll post this.
Yeah.
Bye, guys.
Bye.
Bye.